All right, we are here for honors physics, taking a look at projectile homework worksheet 2, problem number 7, the last problem on the homework set. It says, a shot putter launches a 7.5 kilogram shot with a speed of 12 meters per second at an angle 37 degrees above the horizontal. If, upon release, the shot was 2 meters above the ground, determine the horizontal range of the shot. So here we have that big metal sphere. That's the shot put, the shot that you do in shot put. And it's starting off 2 meters up above the ground. So it's like, it's up around the guy's shoulder height or whatever, right? Or I guess when he throws it, whoops, it doesn't look like level ground. When he throws it, he's going to extend his arm, and we get like at the extent of his arm when he lets go of it, whenever he leaves his hand, right? So it's going to take off at some upward angle here of 37 degrees above horizontal, like that, right? At 12 meters per second. I know I'm going to need to split this up into horizontal and vertical pieces, right, into components. I know that angle there is 37 degrees. Okay. We know that it's taking off from 2 meters above the ground. And we want to know the horizontal range. We want to know how far out it goes. So that shot is going to be put, right? And we are trying to find that horizontal displacement. Ta-da! All right. So I might even just right away go ahead and find the components of this. And again, this is the adjacent side, so I'm going to use cosines. This is 12 cosine 37 degrees. This is the opposite to the angles. This is going to be the hypotenuse times the sine of the angle. 12 sine 37. I just write it right on the diagram, right where I need it, when I need to reference it later. It's right there. Okay, so now I like, that we are going to go from here. We want to know the horizontal from here to here. So we're going starting here, ending here. That is what we're going to analyze. And so I'm going to make my chart, my table of values. I'm going to say horizontal axis and the vertical axis. A V naught V displacement and time. A V naught V displacement and time. Wonk wonk. 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 And I know the acceleration of the x is 0. I know the acceleration of the y is negative 9.8 meters per second squared, because I am going to call right and up positive. And you say, okay, this is the givens for every projectile problem. Now let's fill in what we know here. And you say, hey, we've already figured out a bunch of stuff. We know that horizontal velocity is 12 cosine of 37 degrees. We know the initial vertical velocity is 12 sine of 37 degrees. Do we know the ending vertical velocity when we get to the end here? No. Is it going to be 12 sine 37 just opposite? It will be minus 12 sine? Nope, that's only if we're at the same height. It's going to be faster than that. It's going to have fallen some more. So we don't know that. Do you know how far we go horizontally? That's what we're trying to find. Put a question mark there. Do you know the vertical change? You say, yeah, it's going to be, careful, negative 2 meters. We're going down 2 meters, right? Because we're doing the, remember, we're showing the motion of the shot. It's going to end up 2 meters lower than it started. And the time, we don't know anything about the time to there. So this is what we have. We say, hey, there wasn't a whole lot that we had to just remember in this problem, right? Why is that? Because this is a type 3 problem, right? Where it takes off at an angle but ends at a different height. And so there wasn't that whole long list of stuff that we had to remember, okay? Just the stuff that's true for every projectile problem with the accelerations. So that's kind of nice. They had to tell us a lot of information up front. Hey, look, I'm trying to find this horizontal displacement. We know that in the x-axis, we always use the formula. For the horizontal axis, we're going to use displacement is velocity times time. We're trying to find this displacement. Do we know the horizontal velocity? Yes, we do. 12 cosine 37. Do we know the time? No. So that's two things we don't know. So we got to find time from the vertical information. So I go to the vertical axis. You say, I've got A, V naught, delta Y, looking for T so that I can use it over here. I want the formula that doesn't have V. That is this one. Delta Y is V naught T plus 1/2 AT squared. Substitute in my values. -2. Initial vertical velocity is 12 sine 37 times T that I don't know, plus 1/2 -9.8 T squared. So you say, okay, hey, look, I've got an equation that has just one variable, and that's T. But unfortunately, I've got a T squared term, I've got a T to the first power term, and I've got a T to the 0 power term. You're saying, uh-oh, I'm going to solve this using a quadratic. Or, better yet, my calculator is going to solve this using a quadratic. So here's how the cheesy way that I solve quadratics with my calculator. I'm going to go ahead and I'm going to use the solver program. So to do that, I'm going to go to the math, and there's a list of built-in functions. It's the last one on the list, so I'm going to go up to get to the bottom of the list. I'm going to arrow up. Hey, look, there it is, solver. Enter. And now go up here to this first line. It says equation solver. And in here, I can type in the equation. I'm going to clear it. Type in the equation that I want it to solve. So this is going to be an equation of the form 0 equals, So I'm going to move this 2 to the other side. So I'm going to add 2 to the other side of the equation. So I'll have 2 plus 12 sine 37 times t. And then can I do half -9.8? So that's minus 4.9 t squared. Okay. Yes, I could resolve this 12 sine 37 ahead of time and get a decimal approximation, but I'd rather carry it, you know what I mean, let the calculator have all the digits. Anyway, so equation solver, the way I'm going to do that, I want 2 plus 12 sine 37, close parenthesis. Now I want to multiply by the variable, so times, and the variable is going to be this key that says x, t, theta, and bink, it shows x. Minus 4.9 times the variable squared. So I'm going to go back here with the variable button, x, t, theta, and then squared. So that's the expression. I hit enter. It has the expression in there. Now what it wants, here it says x equals. What it wants there, that is not the answer. What's there right now? It wants me to punch in a first guess. Okay, here's what this program's going to do. Do we have an estimate for what we think the time's going to be for this to go up and come down? Well, it starts off 2 meters off the ground. That's not that far for something that accelerates down at -9.8. I have a feeling 12 sine 37, even if it was 12, it's going to slip. I'm going to put just like 2 or 3 seconds, okay, for my just first initial guess. I'm just going to guess 3 seconds. Now we'll guess 2 seconds. So I'll put a 2 in. Here's what the program will do when I tell it to solve. I'm going to tell it to solve by hitting alpha, and see above enter in green there, it says solve. Can you see that? It says solve right there. So I'm going to hit alpha and solve. When I do that, it's going to take that value 2, and it's going to plug it into the equation. It's going to check that number and say, is that a solution? If it isn't, then it'll check a value to the left. If that isn't, it'll check to the right. It'll check to the left. It'll check to the right. And it'll move out from 2, ding, until it hits a solution. And then it'll tell me that solution. So if I go ahead and I say alpha solve, it thinks for a second, and then it says 1.712. Oh, 2 was not a bad guess. And so it's reporting to me that t could be 1.712, and I'm rounding that, seconds. You say, but wait a minute. It's a quadratic. It's a second order. That means oftentimes there's going to be 2 roots of the equation, 2 solutions. Yeah. So I found one solution. It was at 1.7, right? I started at 2, and that was the first solution it hit. So there could be another solution way off to the right of 1 point, way greater than 1 point. And there could be one off to the left. You know what I mean? 2 just happen to be closer to this one. So I might just substitute in a value that's really big and see if it gives me the same value. We'll put in, I don't know, 100. There we go. And we'll tell it alpha solve. It thinks, and it says 1.712. You say, see, that was the root. The other one must be on the other side of 1.712. So I'm going to put in, like, say, negative 100 and say alpha solve. And it thinks, and it says, oh, the other solution is negative 0.238. All right. What's the meaning of this answer? Which of these do you think I need? Here's the deal. Your calculator just knows that you plugged in the equation of a parabola. And you asked, hey, when am I 2 meters below the starting point? And you say, and it doesn't know that it started here. It just says, you know what I mean? It doesn't know about, it just goes forward and backward in time. It just traces out the whole path and says, oh, when am I 2 meters below this height? And the calculator says, oh, well, it would be in the future 1.712 seconds, or in the past 2.238 seconds. See what I'm saying? It's giving you the time when it would be here if it was moving in this parabola for that whole time. See what I'm saying? We don't want that one because we were never actually down there. We want this answer. Okay. So that's using solver in your calculator to solve a quadratic. I'm a big fan. Now, to be honest, with the way that most students will solve, they won't use the solver program. They'll graph the equation, right? They'll make a graph of the equation and then solve for the intersections where it intersects the x-axis is what they'll do instead. Okay, and if you're more comfortable with that and you can do that, then that's fine. But I find the solver program to be pretty quick and painless. Alrighty, and pretty direct. Okay, so here we go. Now I know the time. My job is to find the horizontal range, so I can put this time into that equation where I see t. My delta x is going to be that horizontal velocity, 12 cosine 37, multiplied by the time that I just found, 1.712. Cosine 37 times 1.712 seconds. And I get a horizontal displacement of 16.4 meters. That's my answer. All right. Hope this was helpful for you. And you saw kind of maybe what might be a new trick for you with your calculator. The interface looks a little bit different on some of the different models of TI, but most models have that solver function in them. All right, and we've solved a type 3 projectile problem now. One more side note I'll just mention, and that is, did you know that when you're at the peak of a type 3 problem, your velocity is horizontal, isn't it? If I covered up the left half, this looks just like a type 1. And so some of the techniques used in type 1 you can use in a type 2 problem. But didn't have to use that here because they weren't asking anything about the peak. All right. That's it for homework set for projectiles, homework 2.